In this series of videos, I'm going through the details of Excel Solver. Here's the plot. So the installation was in previous video. And then we're gonna talk about solve the single equation and then solve the system of equations with solver. And there are two contexts, two sub-scenarios. One is without constraint, the other is with constraint. And last, we are to solve the more complicated market equilibrium conditions. So let's go ahead and do the first one. Solve the simple equation. So we start from very simple. It is 36 minus 3x equals to 48, and we are solving for x. So first, we are to write down what question are we looking at, what equation are we looking at. 36 minus 3x equals to 48. And here we are solving for x. So this is a pretty simple one that you can easily solve by hand, but I'm using this small example. Maybe you can already eyeball the result. So 36 minus 48, that is minus 12, and 3x moved to the right-hand side is positive x. So it's minus 12 equal to 3x. X should equal to minus 4. So let's get to this. So here we just keep our fidelity to the original way of writing this equation. The right-hand side is 48. The left-hand side, also, don't forget to have x and the cell underneath, which is the value of x. So the left-hand side is 36 minus 3 times of the value of x. So we just exactly follow this. So now the value of x is empty, left empty. So by default, it's recognized as 0 by Excel. So what we are doing here then is to solve it out. We are using Excel Solver. Okay, so set objective, we always use the one that includes the variable. So here that is supposed to be this one, A5, because the right-hand side is just a fixed number. You can't change it anyways, right? So we want to set the changeable left-hand side equals to the right-hand side. Here, previously we put the right-hand side as 48, and now we can just refer to this. You can't directly invoke the cell, but here you just type in manually. And then by change the variable cell, what you have to change, actually the one that you're looking for, the x, right? We're changing x to make sure that left-hand side holds its equality to the right-hand side. We don't know if it is non-negative or not for the x that we are solving. So we just uncheck that. And here we're solving for the result, which is -4. So that is the first one that we are looking into. So I'll just change the title of the worksheet to make it clear. So now let's look at the second one, which is a series, including 2 questions. So the function is y equals to 38 minus 3x. So let's get to this. Y equal to 36, minus 3x. Okay, so this one, and first we are to solve the root. The root actually means that this line crosses, when this line crosses the x, the horizontal axis. So we are working for the x-intercept. So the first one is to find the x-intercept, namely the root. Okay, so for the x-intercept, there is no height. So it should be that y equal to 0. So that's the one that we are looking into. So here, how many variables do we have? 2, x and y. And we are to color out the cells underneath, which are the values that we are invoking later on. So this function has its left-hand side and right-hand side. The left-hand side is actually y. So I'll just put it I'll just swap the left-hand side and right-hand side to maintain the consistency. So the left-hand side is y, so I just directly invoke the value above, which is y, which is the value of y, and the right-hand side is 36 minus 3 times of x, and here we need to invoke the value of x. Okay, so this is the setup, and then we are to work out the x that makes y equal to 0. Okay, so here, this is just the default value. Don't think it's already there. Okay, so let's do the calculation, solve. So what we have to do is to set the objective, which is the right-hand side, which is one that is actually changing, right? To make this value to be 0, okay, by changing the variable cell, which is x. So here, y is given to you as 0, right? So here, in this case, the y is known, which is given to you as 0. So actually, you don't have to color it. So the only variable, true variable here, the only one that actually changes here is x. We're finding the x to make y equal to 0, namely to make this equation 0 equals to 36 minus 3x to hold. Okay, so that's what we are doing. So sometimes those additional information is elusive, if you will. So we are to make sure that 36 minus 3x, which is here, okay, equals to 0 by changing x. So the result is 12. So here you may see this -1 whatever. And don't fret, -1e to the power of 6. Actually, if you change the format of the cells, say, go to number, and here change this into number and keep, say, 3 decimal places. And you're gonna see, we're actually finding the x, which is 12, to make y equal to 0. So that's the first version of this question. So I'll just label it as A, point A. And the second version of the same question, which is point B version. The previous is the same. Just copy and paste. Okay, so the second one is when y equals to 12, what's the result? We have to solve for x so that y equals to 12. So here, x and y equals to 12. So we are to solve for x so that y equals to 12. Okay. So here, we can still do, say, left-hand side, and right-hand side. And here, the right-hand side equals to y, which is 12. But the left-hand side is the one that is really changing. Be able to recognize this is very important. So here, the value of y is given to you. So even though it's a dependent variable, but it's already telling you the value is fixated at 12 for y. So the only one that is allowed to vary is x. And here, the right-hand side, of this equation is 36 minus 3x. So that is 36 minus 3 times of x. So now we are finding the x, that's the variable that you're changing, to make sure the right-hand side, which is 36 minus 3x, okay, to be of the value of the left-hand side, which is 12. So the value should be 8.